Welcome back, everyone! Today, we are getting our hands dirty, well, figuratively speaking, with a deep dive into the EPH Trading PLC Smart Soil Sensor Manual. If you've ever wondered exactly how modern farming is ditching the old-school guesswork and stepping straight into the future, you are absolutely in the right place. In this explainer, we're going to unpack how this incredibly smart little device is totally modernizing traditional farming methods. We'll take it right from the basic unboxing all the way to some seriously advanced agricultural analysis.
Okay, here's our roadmap for today's explainer. We'll kick things off with the precision agriculture revolution, move into hardware and connectivity, break down that 8-parameter analysis, look at crop standards and yields, and then wrap things up with maintenance and future outlook.
All right, let's jump right into Section 1, the Precision Agriculture Revolution.
So to really appreciate this tech, we kind of have to understand the stakes here. In modern farming, getting immediate, accurate data isn't just a luxury. It's literally a matter of life and death for your crops. Think about traditional farming methods for a second. Testing soil meant agonizing 24-hour wait times at a lab, or worse, messing around with genuinely hazardous chemicals like boric acid out in the field. Slow, tedious, and honestly, pretty dangerous. But this smart sensor, it's the ultimate solution. It completely bypasses all those hazards, delivering instant, perfectly safe, on-site results straight to a smartphone screen. The sheer amount of time and physical exhaustion this saves is just staggering. No, what's really wild is the massive amount of data we're talking about here. 8. This single device analyzes 8 different key soil characteristics completely simultaneously. You heard that right, 8 distinct metrics captured at the exact same time. So calling this an 8-parameter analysis revolution, honestly, isn't an exaggeration at all. Let's move on to Section 2, Hardware and Connectivity. You know, having state-of-the-art tech is completely useless if you need a PhD just to carry it around, right? Well, at an ultra-compact 70 millimeters in total length, this whole device literally fits in the palm of your hand. But don't let the tiny footprint fool you. Attached to that little body are 56 millimeter probes. They're specifically engineered to penetrate the soil deeply enough so the data collected is actually accurate to the root zone of the plants. And the setup process? Oh, it's brilliantly simple. No messy wiring, no complicated pairing. First, just scan the QR code right on the back to install the app. Then, for that flawless hardware connectivity, you just plug it right into your phone via Type-C cable. Boom! It works flawlessly with both Android and Harmony OS. And hey, if your phone doesn't recognize it instantly, just pop into your settings and toggle on OTG, that's on-the-go mode. Finally, shove those probes into the dirt and you've got results on your screen. Absolutely zero computer science degree required.
Which brings us to Section 3, 8-parameter analysis.
Okay, let's get into the nitty-gritty of the data precision here. Starting with moisture. The sensor uses FDR technology. That stands for Frequency Domain Reflectometry. Now, why is that a huge deal? Well, if you've got highly saline, meaning really salty soil, older TDR methods would just get completely confused and throw off your moisture readings. But FDR technology? It guarantees flawless, highly accurate moisture readings regardless of that soil salinity. It is a massive technological leap over the older methods.
And getting accurate moisture readings is critical because, well, dirt isn't just dirt. Knowing your specific soil type is step 1. For instance, sandy soil only needs about 8 to 22% moisture to be perfectly healthy. But if you're dealing with dense clay, you might need up to 45%. The sensor gives you the exact percentage, but you absolutely need to know what kind of earth you're standing on to apply that data correctly.
Next up in the analysis is the soil pH scale, so your acidity versus alkalinity. The precision here is mind-blowing, accurate to plus or minus 0.2. If your reading comes in under 4.5, your soil is highly acidic. Above 9.5, highly alkaline. But there is a magic neutral sweet spot right between 6.5 and 7.5. Keeping your soil in that specific range allows your plants to easily and efficiently absorb vital nutrients. It's basically the ultimate growth environment.
Then we have EC, or electrical conductivity, which measures the dissolved salts in the soil, and this is vital to monitor. The ideal happy growth range is between 100 and 1,000 microsiemens per centimeter. If that reading spikes over 2,000, it's bad news. It will severely damage or just outright kill your crops. Having this instant data on hand lets a farmer catch that dangerous spike right away and fix it before the whole harvest is ruined.
The sensor also tracks 3 absolute powerhouses: nitrogen, phosphorus, and potassium, We usually just call them NPK. Nitrogen is your accelerator. It speeds up overall growth. Phosphorus is the builder. It strengthens the plant and aids photosynthesis. And potassium is your shield. It builds resistance against diseases and nasty droughts. By instantly grabbing these three crucial chemical levels all at once, you literally have direct, perfectly balanced control over your plant's diet.
All right, let's look at Section 4, Crop Standards and Yields. So let's take all this cool data and apply it to the real world. Different crops demand wildly different soil environments. An apple tree, for example, has a surprisingly high tolerance for salt. It can handle an EC level all the way up to 1610. Carrots, on the flip side, naturally prefer much lower pH, acidic soil. The point is, when you have an 8-parameter sensor, you aren't crossing your fingers and guessing anymore. You are matching the exact scientific reality of the soil directly to the biological needs of your crop.
There's also this incredibly fascinating excerpt right from the manual regarding native crops. It points out that establishing accurate EC and pH baselines for native crops, like teff, actually requires further local scientific research. Now, that's not a limitation. That is a massive, wide-open opportunity. It's a clear call for local agricultural researchers to take these international standards, use this precision tech, and completely modernize the cultivation of native crops.
Finally, let's wrap up with Section 5, Maintenance and Future Outlook.
Okay, rapid-fire care instructions, because we want this investment to last. First rule, absolutely do not disassemble the device. Just don't do it. Second, keep it far away from harsh chemical exposure. Third, always store it somewhere perfectly dry. And lastly, like we mentioned earlier, always insert those probes fully into the soil to ensure you're getting perfectly accurate readings. Really simple care rules, but they guarantee a long life for the sensor.
So, I want to leave you with this to chew on. How will instantly accessing 8 vital soil parameters change the future of global food security? We are actively modernizing traditional farming right now. We're stepping away from that slow, hazardous guesswork and moving into a world of instant data delivered via a simple Type-C connection. With innovations like FDR moisture readings and real-time NPK monitoring, we are totally revolutionizing agricultural productivity. Just imagine the yield growth we'll see when every farmer on the planet is armed with this exact knowledge. Thank you so much for joining me on this explainer. Keep learning, keep asking questions, and I'll catch you in the next one.